Today we're going to talk about factoring the greatest common factor out of our polynomials. When I look at this, I'm going to start by looking at the 15 and 12, and we're going to think back to finding our greatest common factor. To do that, we would do our prime factorization. So this is 3 times 5. This could be 2 times 6. But then 6 is not prime, and we would break it down to 2 and 3. Okay, so that's our prime factorization of each of these numbers. Now, to find the greatest common factor, you have to find the one they both agree on. So what do these agree on? Well, they both have a 3. That is the only thing they agree on, so the 3 is their greatest common factor. Now, when you factor, what you're going to do is you're going to put the 3 on the outside, or your greatest common factor, and we're going to look at the 15z cubed plus the 12z cubed. Now we're going to divide each of those by your GCF. Okay, now when you do that, 15 divided by 3 is 5. 12 divided by 3 is 4. Oops, that was a 2, sorry. And that would be the factored form of the numbers. Now, if you look at this, you can also see that what else do they agree on? They both have a z squared in there. Okay, so what we're going to do is we're going to take out a z squared also. Now, normally you would do this in one step, but I wanted to show you the number first. So I'm going to divide both of these by our z squared. Now, when we do that, you always keep your GCF on the outside. You always put a parenthesis. Now, the 5 is going to remain the same, but this time z cubed divided by z squared. So 3 minus 2 leaves us with 1z. Plus the 4. Now, z squared divided by z squared would cancel out, or 2 minus 2 is 0, and anything to the 0 is just 1. Okay, so this is the factored form of this original equation. Alrighty. Let's look at another one of these. So you've done GCFs before. Okay, you've factored before. Now we just need to look for factoring with possibly a variable also. So let's look at this one. 13 n to the 5th minus 4n. Okay, now I know when I think about 13, it's just 1 times 13. It's already prime. So is there any number that 13 and 4 are going to agree on? No, other than 1, there's nothing. So it's not, our GCF is not a number this time, but instead our GCF is, well, they both agree on at least one n. So we're going to factor out an n. Okay, so the n goes on the outside. Put your parentheses. All right, now we're taking our original equation and we're dividing each piece by that n. When I do that, now I have 13n, 5 minus 1 would leave us with 4, using our quotient rule, minus our 4, but the n divided by the n, they're just going to cancel, and it just stays there. Okay. Let's look at one more. Do you need to do the prime factorization each time? No. For instance, 2m to the 4th plus 10m squared. Okay, when I look at this, I know 2 is already prime, and I know that 2 goes into 10. So I can take out a 2 right away. That's my GCF. Now look at the m's. What do they agree on? Right, they agree on 2 m's, or m squared. So I'm going to take those out, and I need to figure out what is left. So let me write my original, and I'm going to divide by my GCF. All right, which means my GCF stays. It's not going to go anywhere. I'm going to leave that there. 2 divided by 2, well, that's 1. M to the 4th divided by m squared from our quotient rule, 4 minus 2 is 2. So m squared is what's left there. Bring down our plus. 10 divided by 2 is 5. And m squared divided by m squared, 2 minus 2 is 0, and anything to the 0 is just 1. And there is my factored form. Now, when we start, we're going to begin factoring these. This is just one step of our factoring. We can also, we're going to learn quite a few other steps. But once we factor, for instance, let's say we have 3t times t plus 2. We've already factored this one, okay? It came from 3t squared plus 6t, okay? Because I just put it back together using my distributive property. So this was the original, we factored to this, but now we've set it equal to 0. We're going to talk about something called the zero product property. Okay, what that says is, let's see, if I have x times y, let's just look at that for a minute. If I have x times y equals 0, what if my x was 3? What does my y have to equal? Right, it has to equal 0. Okay, because something times 0 will give you 0. Now, what if my y was equal 3? What would my x have to be? Right, it would have to be 0. Okay. The other option is, could they both be 0? What is 0 times 0? It is 0. So this is your zero product property, saying that we can set the pieces equal to 0. When we do that, we will be able to solve for the roots. So if I divide this by 3 to solve for my t, I get t equals 0. Over here, I'm going to subtract the 2 from both sides, and I get t equals -2. Okay, so t could be 0, or t could be -2, or t could be both of these. Okay, we're going to learn soon that this graph is actually going to look like this, and these 2 points are where it crosses the x-axis. So there's the -2, and there's the 0. Okay, this is called a parabola, which is what these are. Okay, and these points are where it crosses the x-axis.